So let's look at problem solving problem 2, this Pokemon problem. So remember, this is the one about Pidgey, and you get candies for transferring it and those kinds of things. So what I found issues for understanding, people who didn't know about Pokemon thought that you had to know about Pokemon in order to do this problem somehow. Like there wasn't enough information in the problem in their head because of Pokemon. That is incorrect. Okay, so there's enough information here to do everything you need to do, but people still had that block because it was Pokemon. I'm going to show a heuristic that might help with that a little later. The other issue I saw students have was they missed out that you got a candy for evolving, or you had to keep a Pidgey to evolve it, or just some of those little reading things. So that was what I saw in understanding the problem. So if you watched my video, you saw me use guess and then check to solve this problem. If you didn't watch that, I'd recommend you check it out, though I would say I'd watch it on double speed just because at the beginning I got a little iPad issues and things like that, so I'd watch it at double speed just to get through it, but I use guess and check as my heuristic. Popular heuristics I saw: make an organized list. I had lots of Pidgeys, lots of clip art of Pidgeys, or hand-drawn Pidgeys. So making that organized list where you show what's going to happen every time you catch one. I also had some people use deductive reasoning. I liked this picture, which is why I kept this one. It was also good work. And then there's a pretty straightforward one. Okay. I would claim that a lot of my students actually used guess and check or trial and error, but all they showed me was their final work. So I think a lot of students use guess and check, but then they're like, I need to show my work. I'll just show the work that I know works out. That's okay, but it's almost as if students think guess and check is bad or trial and error is bad. Those are perfectly legitimate problem-solving techniques. And for this, it works. I think to check your answer, you do need some sort of organized list, but using guess to make sure you're on the right track or that you're on the right number definitely works. Here's a crazy heuristic. Here's a rewriting of the problem. Each time you get a bob, you get $3. You can say goodbye to a bob to get $1. That bob leaves forever. You want to buy Bob a $12 collar and a $50 doghouse. Each of these items has a $1 rebate. You get $1 after you buy them. What's the fewest number of bobs you need to get to have a bob with a collar and a doghouse? Okay, this problem, as I've written it here, is utter nonsense. It means nothing. It's totally unapplicable. However, it benefits from the fact that you don't need to have this concern about Pokemon and how Pokemon work in order to do it. This is the same exact problem with the same exact solution, but it looks like it's different. It looks like it's easier because you don't have that Pokemon part hanging over your head. I also bolted out the key parts, but if you run into a problem where you're really stuck and you really think that something's going on that you don't know, that you're missing information, try rewriting the problem. Even if it's silly like the way I did this one, it may help you be able to solve it. Manipulatives are another way to do this problem. I had many students tell me they used manipulatives. I'm doubtful, but here's what that would look like. So here I'm going to use manipulatives. I've got my pile of pencil erasers there. So when I catch a Pidgey, I get 3. So I move 3 over. When I let it go, I get another one. So now I've got 4. When I catch my second Pidgey, I get 3 more. When I let my second Pidgey go, I get another one. I would do this until I had 12 of them and a Pidgey to evolve. Put 12 back, take 1 out. This would be using manipulatives in order to solve this problem. So manipulatives are when you take physical objects and use them to represent the things. So remember, Polyas' last step is not just finding the answer. It's looking back and examining the answer. First, can you check it? Do you know you have the right answer? Does it make sense? Can you check your argument? Could you get there a different way? If you made an organized list, can you see how you would do it with manipulatives? If you use guess and check, could you have used trial and error? Can you see the solution at a glance? Now that you've solved the problem, can you look at it and say, I know exactly how I did that? Could you use a result or method on other problems? Have you learned anything new? And here's just a couple problems you might try similar to this. So if you started with nothing and you want to evolve 1 Pidgey once for the 12 candies, how many would you need to catch? If you started with nothing and you wanted to evolve 10 Pidgeys once each for 12 candies, how many would you need to catch? If you had 1,716 Pidgey candies and no Pidgeys, How many Pidgeys could you catch, evolve once, and let go before you had 8 or less candies? This is what a lot of Pokemon players actually do when they're trying to level up quickly. Now, Friendship has mitigated some of that, but so for Pokemon Go, this is a way that people used to gain a lot of experience. Not quickly, but quickly enough. A snail climbs a well 3 feet during the day, and during the night it slips 2 feet. If the well is 30 feet deep, how long will it take the snail to climb? This problem is actually pretty similar to the one we did, and in fact, it's the one that inspired me to come up with this problem. So this is a similar type of problem that you should be able to tackle using whatever method you use to solve the Pokemon one. The real key here, and the real reason that we're doing problem solving in this class, and if you're following along in the videos just for fun, hopefully the reason that you're more interested in problem solving is you want to get better at problem solving. The way you do that, you keep thinking about problems you've solved, problems you're working on. You keep solving problems and thinking about problem solving, and you keep thinking about those heuristics. What are the different ways that I could be solving these problems? For whatever reason, at the end of videos, YouTube suggests that you meander on about subscribing and linking to new videos. So I'm going to do a little bit of that now just to try to increase the visibility of this channel because I want people to be better problem solvers.